Hello everyone, I am Malathi from the Department of Mathematics, SNS College of Engineering. This is the fourth video of my second lecture series. Topic is Introduction to Two-Dimensional Continuous Random Variable. First of all, we should know what is continuous random variable. So, if we are measuring anything that comes under continuous random variable. If we are calculating the size of the room, size of the bottle, size of the uh, car, so whatever may be the size of something, we have to measure that. Whatever we are measuring, that comes under continuous random variable. Two-dimensional continuous random variable are essential in probability and statistics. They represent pairs of continuous random variables, providing insights into the joint behavior of two random quantities. Definition and properties of two-dimensional continuous random variable. Understanding the characteristic and behavior of two-dimensional continuous random variable. Exploring the unique attributes and traits exhibited by these random variables. Example, illustrative instance, real-world scenario demonstrating the application and relevance of two-dimensional continuous random variable. Uses the cases, practical example showcasing the occurrence and analysis of two-dimensional continuous random variables. Joint probability density function and cumulative distribution function. So if you are seeing the discrete case, we will have probability mass function. So if you are seeing two-dimensional random variable means joint probability mass function and cumulative distribution function, as well as in continuous case we have to say that as a joint probability density function and cumulative distribution function. So joint probability means we should have two random variables called x and y. If that separated means we cannot say that as a joint probability density function. Suppose if we are considering a square. So first of all we should know what is 2D and 3D. So if we can see the shape, if we can see alone the shape means that is comes under 2D. If we can touch and feel the shape that is comes under 3D. So if we want to measure a square, rectangle or triangle, we should know what is a random variable. Based on this we can find the area of the square, perimeter of the square. And the understanding joint PDF is analyzing the joint probability distribution to model the combined behavior of two random variables. Utilizing CDF, assessing the cumulative distribution function to interpret the probability of a range of values. A marginal probability density function and cumulative distribution function. Marginal PDF evaluating individual probability density function for each variable in the two-dimensional scenario. CDF evaluation analyzing the cumulative distribution function for individual random variable. Conditional probability density function and cumulative distribution function. Conditional PDFs understanding the probability distribution of one random variable given the value of the other. CDF analysis analyzing the cumulative distribution function under specific condition of events. Covariance and correlation. Covariance, evaluation of covariance to understand the level of independence and dependence between the two random variables. Correlation analysis, evaluating correlation to assess the strength and direction of the linear relationship between two random variables. Application and significance. Business application, utilizing two-dimensional continuous random variable in predictive analytics and risk assessment. Scientific relevance, contribution of continuous random variables in scientific experiment and data analysis. Engineering simulation, application of continuous random variable in simulating complex engineering scenarios and system behaviors. Thank you. Especially in business, we can predict the upgrade or average or how we are going to face the loss using the continuous random variable. We can track the gradual growth or instant growth or super growth through the continuous random variable. In this continuous random variable, we are using this wisely in business field as well as scientific relevance as well as engineering simulations also. In engineering simulation, we could have